Welcome back. Today we're going to talk about significance tests for paired data. In the previous section, we talked about significance tests for a set of two sets of data, right? So you've got this population, you take out two samples, and you have data from each of the two samples. The difference here with paired data is that paired data would be like one person undergoes two different treatments, and we look to see if there's a difference in the way those two treatments were in that one person. Or you have two samples, but they're paired by their similarities. And so at the end here, we're going to go through a couple of formulas here. But at the end, we're going to look at a couple of situations, and we're going to determine: are we talking about two samples, or are we talking about one sample? Are we talking about a paired T procedure, or are we talking about a T test for two samples? So let's talk about what it looks like to do the significance test for this. The good news is that the four-step process still remains the same. And if we're going to do a significance test, you still have to meet the conditions. You still have to meet the normal. You still have to meet the 10%. But the one sample T test that we're going to perform here, so it is a one. Ooh, that is a highlighter. Let me get rid of that. One sample T test for the mean difference. So there's one sample. I took out one sample and I did two different things to them. And so that would be like me going and seeing if caffeine affects me. And so what I would do is I would be part of the sample group. There'd be 10 of us. And so one day I would measure my heart rate and then take a drink of a beverage that I didn't know if it had caffeine or not in it, and then measure my heart rate afterwards. And then a day, maybe two or whatever later, I'd go and I'd drink the other one, and then we'd measure my heart rate. So both of the treatments are being done to me. And so then at the very end, if I'm subject one, we'd say subject one in the first test was this, second test was this. And so that's paired data because the treatments are both happening to the same person, as opposed to me saying, oh, compare my caffeine consumption with some other subject. Okay, so I'm comparing amongst or in a group where I'm comparing in just one person the difference. And so our T value here is going to look pretty similar. So it's going to be my actual difference, so my difference from me minus the hypothesized mean difference. So if this is a significance test, I'm still going to write those hypotheses, and maybe my hypothesized value is that there's no difference, so that would be like whatever my difference was minus 0 or something like that. And at the bottom, and these should look different, these should look familiar. Still do the standard deviation and divide by the square root of n. The big question is it one sample or two samples? Here's how we determine it. We would do one sample if the design is like a matched pairs. So matched pairs design, and earlier in the year we talked about GPA, right? So you may not have two people with identical GPAs, but you take the top two people and you'd say, okay, these are our most similar. Then you take numbers 3 and 4 and you'd put them up as most similar, so you'd compare those. And so one sample would be when you're determining people with very, very similar characteristics, or a matched pair. And what you do is you subtract their results, and then you find their average. Excuse me. Subtract and find their average. So for example, in that GPA, in that GPA example, you would do, 1 and 2, you subtract to find the difference. 3 and 4, subtract to find the difference. 4 and 5, or 5 and 6, subtract to find their difference. And then you average all those differences. And that would help you to come up with one mean. In a two sample, you'd be doing something like having two groups or any type of situation, so two groups or two samples, where you'd end up with two separate means. To give you a GPA example to kind of juxtapose that matched pairs design that we did, it would be if you did groups of seniors from two separate high schools, or a group of juniors and a group of seniors. You'd find the average for the juniors, you'd find the average for the seniors, and then you'd compare those. In this case, you'd be averaging, then subtracting. Right? So if you have the two groups, you'd find the average for the juniors, the average for the seniors, and then you subtract those two means to find out is there a difference. Let's go through a couple of examples, because at the outset, I think with this particular skill, right, it seems like, oh, that makes sense, but then we put it in context and that could sometimes be a little bit confusing. So all we're doing on this is determining, would we use a one sample or a two sample? So would we have more of a matched pairs design where we subtract the results and then average them? Or would we have two separate groups, two separate samples, and we find the average of each and subtract them? So let's kind of look at the distinction here. Each of the settings, you should decide whether to use a two-sample T procedure to perform inference about a difference in means, or a paired T procedure to perform inference about a mean difference. Explain your choice. Let's see. Before exiting the water, scuba divers remove their fins. A maker of scuba equipment advertises a new style of fins that's supposed to be faster to remove. A consumer advocacy group suspects that the time to remove the new fins may be no different than the time required to remove the old fins on average. So they've got this hypothesis, right? We think there's no difference. So 20 experienced scuba divers are recruited to test the new fins. Each diver flips a coin to determine if they wear the new fin on the left foot and the old fin on the right foot, or vice versa. The time to remove each type of fin is recorded for every diver. So think in your head here. Is this going to be a one sample or a two sample? Is it a case where I have two groups doing something and then I'm finding the average time and subtracting them? Or is it one group and that one group is doing both things and then I'm going to find the average time difference in this case? Well, hopefully you said that this was a one sample. Okay, and we should use a paired T procedure. Because each diver is doing both things. Each diver is they're taking off both fins. And so it's two measurements from each diver. So what would this look like if it was a two sample? It'd be, you take a group of 20 experienced divers and another group of 20 experienced divers. You give these divers all the new type of fin. You give these divers all the old type of fin, and you see who takes longer. And so you can kind of see why in this case. So you could do that, right? But you can see in this case, because if I'm a person and I have a certain amount of time it takes me to take off my fins, right? And it's different for each person. If I'm taking off each type of fin and I don't know necessarily, if I don't know which foot it's going to be on, right? So if I'm equally likely to take off my fin from the same, if I'm equally likely to have the same amount of time to take off my fin from my left or right foot, whatever, it's advantageous to have me do both because I am the person and it takes me a certain amount of time to take off the fin. Okay. Part B. To study the health of aquatic life, scientists gathered a random sample of 60 white piranha fish from a tributary in the Amazon River during 1 year. The average length of these fish was compared to a random sample of 82 white piranha from the same tributary a decade ago. So ask yourself, same thing being done to two groups, or same thing being done to one group, or two different things being done to one group? And I think what you'll see is this is a two sample T. This is a two sample t-test. Data came from two separate groups. And hopefully you kind of see this, right? Because they said the average length of these fish was compared, right? The average length of fish. So they found this group, they found the average of that group, had this average. They took this group, they found its average, and then they compared the two averages. Okay, that's the nature of a two sample t-test. Part C, can a wetsuit deter shark attacks? A researcher has designed a new wetsuit with color variations that are suspected to deter shark attacks. To test this data, she fills two identical drums with bait and covers one in the standard black neoprene wetsuit and the other in the new suit. Over a period of 1 week, she selects 16 two-hour time periods and randomly assigns 8 of them to the drum in the black wetsuit. The other 8 are assigned to the drum with the new wetsuit. During each time period, this appropriate drum is submerged in the waters that sharks frequent, and the number of times the shark bites the drum is recorded. Is it the same thing happening to one thing, or is it a case where we have two separate groups and we do the experiment to one, find the average, and then do the experiment to another and find the average? This, hopefully you said, is a two sample. And I think what can be confusing about this one is like, well, it's the same tank, it's the same drum, what's the big deal? But it's how you're doing the procedure. Notice, they said, during each time period, the appropriate drum is submerged in waters that the sharks frequent, and the number of times the shark bites the drum is recorded. So they have this time period, and they're saying, during this time, this is what happened with this wetsuit material on. We find that average. During this time, we put a completely different wetsuit on, and we found the average. Okay, so this is a two sample T. So data come from two separate groups of 8 hours. So the time frame of 8 hours is one group, and the other time frame of 8 hours is the other group. Okay, guys. So that's and don't hear me gloss over this, but our procedure that we would do here, our state plan do conclude our significance test, would look exactly the same. It's just how we execute that particular test, and it would be us naming the procedure one sample t-test and finding it using our hypothesized value. If we're hypothesizing that there's no difference, or if we're hypothesizing whatever the difference happens to be, it's just the way that you start the test given the data. But then from there, your state, plan, do, and conclude flows. Okay? So thanks for watching. Let me know if you have any questions, and we'll see you next time.